Why?
So, the goal of our project was essentially to make this car go around these three cups in an alternating pattern. Sort of like you might see in, like, ski racing, except way slower. The first thing we had to do was figure out where the actual cups were, which kind of turned out to be harder than we anticipated because initially we tried using a neural network trained on images of cups to actually be able to detect them and not have any false positives for other random red things in the room. But that actually didn't end up working out. It actually gave us more false positives than just using the color red, and also it was extremely slow. And we really needed to be able to react quickly to any red cups that we were seeing because otherwise the car would just sort of veer off into oblivion. So what we essentially ended up using was a very lightly modified version of the color tracking node from the other project. This was pretty reliable at actually detecting the cups without giving too many false positives because there aren't that many big red things in the GDC. So for our purposes, it actually ended up working pretty well. So at this point, the problem was just actually being able to navigate the cups without missing any or hitting any by accident. We also had to find a way to fine-tune the evasive maneuvers the cars were making because their swerves tended to get a little bit overzealous. We eventually settled on a two-phase method of actually navigating the cups. In the first phase, which we called the approach phase, the car would locate a cup within the camera that was close enough to be considered part of the course. Then it would actually approach the cup with it in the center of the screen and eventually get close enough that it would enter the second phase, which we would call the swerve cup phase. And at that point, the car would pivot to one direction and go until the cup was no longer inside the screen. At that point, it would start to turn the opposite direction and go until it saw the next cup, at which point it would re-enter the approach cup phase and repeat the cycle all over again. All the color detection and navigation logic was handled by colortracking.cpp. The color tracking node would switch between the two modes, and based on the position of the cup, it would send navigational directions to control.cpp. The control node would then interpret those directions and use them to actually drive the car in the direction it needed to go. So eventually, after a lot of failure and a lot of tampering, we were eventually able to get the whole thing to work. Here's a multi-angle shot of one of our first successful runs. And here's one long clean shot. Ultimately, after a troubling few weeks, we were finally able to actually create a car that was able to weave between an arbitrary number of red solo cups without hitting any or veering off the track. It's able to do this fairly reliably and without too much stop and go, which is about as much success as we'd been able to expect with this project. The variance in the speed of the cars made it difficult to actually execute the maneuvers we needed to do, but by taking things slow and optimizing our image processing, we were ultimately able to get our car's reaction time up to where it needed to be. Despite problems that persisted up until the very end of the project, we were able to collaborate and get things done even better than we thought we would be able to in the first place. All in all, we'd consider this project a pretty huge success.